lipids video number 2. In the last video, we stopped with the discussion of the different melting points according to what is the length of the hydrocarbon chain of the fatty acid and also the level of unsaturation. Now we're going to introduce what is that we call the triacyl glyceroids, and that will be the unit of glycerol, which is the triol, that is a 3 carbons long triol that is called, instead of 1, 2, 3 propane triol, we call that glycerol, that will react with 3 different fatty acids to form 3 ester bonds. But before doing that, let's take a look at the little summary of what we have done. The first thing is, we said that lipids are water-insoluble substances. There will be no branched with some exceptions. For example, those fatty acids forming membranes for archaea, those will have some kind of methyl groups every 3 or 4 carbons, but the majority of carboxylic acids that are fatty acids are unbranched. The size of the fatty acids is between 10 and 22 carbons, and it will have an even number of carbons because they are synthesized from acetyl-CoA with 2 carbon units at a time. They will be divided between saturated and unsaturated, being mainly a cis double bond. And these are very important. These are what is called the oleic acid, that is 18 carbons long with 1 double bond, linoleic acid that has 2 double bonds, and linolenic acid that has 3 double bonds. All of these have the same length, but the level of unsaturation will influence what will be the melting point. And now also to overview what is that called the partial hydrogenation. If we have a 22 carbons long molecule, after partial hydrogenation, which is the same reduction that we have done with alkenes, we can get 2 different kind of products. One that is the trans fat that is not good for us, and also what is called the saturated fat. And this is actually very useful to convert very good healthy oils like corn oil, soy oil into margarine, just because of the food industry make it easier to spread. Now we have waxes, and waxes we say that are the product of the reaction of a very long hydrocarbon chain carboxylic acid that has reacted with a very long hydrocarbon chain alcohol. Let me put a number here like N, and then the product will be, if we just do this as a cartoon, a very long hydrocarbon chain wax or ester. So that is a wax, and the function of a wax is to protect surfaces like the apple skin, berries, also the coat of some animals like the feather of dogs and some birds. Some berries, they will have a protective coat of waxes that are produced from the reaction of carboxylic acid and a long hydrocarbon chain alcohol. Now the next thing is the discussion of triacyl of glycerols. As we have said in the previous page, that is the reaction between the unit of glycerol and 3 different fatty acids. And those fatty acids do not need to be the same necessarily. For example, I have created 1 triglyceride or triacyl glycerol that contains 1 fatty acid that is saturated, 1 that is a monounsaturated, and 1 that is a polyunsaturated. Then what will make an oil or a fat? Because a fatty acid alone is not what we find in animal fats or in oils from plants. For example, olive oil, canola oil, peanut oil, they contain different fatty acids attached to the unit of glycerol. The level of unsaturation will determine if that is an oil or if it is a fat. If it is a fat, like animal fat found in the chicken breast, that will contain mainly saturated fatty acid. And one that the students have done in the chemistry lab is trimyristin. You guys have isolated trimyristin, which is, you have the same thing, we just do here a little E, and that was the unit of glycerol, which has reacted with 3 units of myristin. And myristin, as it is 14 carbons long, as it says in there. Let me just put here a 14 without counting the carbons. So don't email me about that. But you have already worked with one of these triglyceride, which is the unit of glycerol upon reaction with 3 fatty acids, and that is trimyristin that you guys isolated from nutmeg.